So this is problem number 15 on study guide number 1 for the chapter 4 test. And as you can see, we need to draw a rectangle here that has two sides on each axis, and then a vertex, and one vertex on the curve y equals negative ln x. So if we put 1 right there, we know that ln of x looks like this, goes right through 1, 0. But if we put a minus sign in front of the ln x, we know that the minus sign goes like this. The minus sign reflects the ln of x across the x-axis. And so that's what it's going to look like. Y equals negative ln x. And so if we label our rectangle as the x coordinate, so the x is the distance between the origin and the right side of the rectangle, then the height of the rectangle is just y, but y is negative ln x. Okay, so the height of the rectangle is the value of the function, because the value of the function is the y coordinate of the point on that graph. Okay, the x coordinate of the vertex for which the area of the rectangle is a maximum. So we want to maximize, maximize the area. So we need to figure out what the area of the rectangle is. But as you can see, the area of the rectangle in terms of x is just the length of the rectangle, which is x, multiplied by the width or the height, whichever way you want to look at it, negative ln x. So we have a function, we're trying to maximize it, and so the first thing we want to do is we want to take the derivative, and let's clean it up just a little bit. So if we take the derivative, a prime of x is equal to, so I don't want to mess anybody up, let's put a prime of x is equal to, and I'm running out of room over here, but we'll figure it out. We have the product of two functions. One function is the negative x, and the other function is ln of x. And so if we want to take the derivative of the product, we take the first, multiply that by the derivative of the second. Now the derivative of ln of x is 1 over x, okay, plus the second function, ln x, and multiply that by the derivative of the first function, and derivative of negative x is negative 1. Okay, so let's clean this up a little bit. In fact, let's use a different color, and let's move it down here. A prime of x is equal to, so if we multiply the first two terms together, negative x times 1 over x, we just get negative 1. And then we can see we have minus ln x. Okay? So if by chance, if you think about this, if by chance we look at the domain of what x could actually be, if we move x all the way out to 1, then we would see we'd have a rectangle that had length of 1, but it would have a height of 0. So if we send x all the way out to 1, we know that that's going to give us a minimum area. So we can be pretty sure that whatever x we find, that whatever critical point we find for x that would make a prime equal to 0, that's going to be a critical point that's going to yield a maximum area. Okay, so you can prove that if you'd like to, but I'm just telling you that's the way it's going to be. So let's go ahead and solve this equation. The equation negative 1 minus ln x equals 0, because that's where we're going to find our possible critical points. And if we add ln x to both sides, we get ln x is equal to negative 1. And you should know that in order to solve this equation, you would convert this to exponential form, and you'd see that e to the negative 1 is equal to x. And e to the negative 1 equals x. That's the only critical point. That's the only value of x that would make a prime equal to 0. And like I said, if you make where could I put this? It's so difficult to make decisions here. So our smallest value of x, I'm going to make a little sign chart just to reiterate what I said. The smallest value of x would be 0. Now if x is 0, that wouldn't make any sense, because ln of x can't be 0. So it does, though, provide us a left-hand endpoint. In fact, x can't be 0, but x could be just bigger than that. And then the right-hand endpoint would be 1, because x can't be bigger than 1, because that wouldn't make sense in terms of drawing the rectangle the right way. because it says the rectangle is drawn in the first quadrant. So if x is bigger than 1, then you've got a rectangle that comes down here, and that doesn't make any sense. So therefore we've got x equaling e to the negative 1, which is 1 over e, and that would give us our only critical point. And it seems pretty redundant though, but I'm going to go ahead and do that. If we did check a prime with a test value, like let's say 1 over e to the third power, we know that that's smaller than 1 over e. Well, that would be e to the negative 3, negative 1 minus negative 3. That would be a positive value. Okay, that would yield a prime being positive, and then in between 1 over e and 1, I don't know, what would be a good value here? I don't know, e to the, it's not a great value here. 1 over e to the 1, 1 over e to the 1 half, how about that? Okay, 1 over e to the 1 half. Would that be bigger? Yeah, as the denominator gets smaller, the fraction gets bigger, and that's certainly smaller than 1 as well. Anyway, if we replace x with e to the 1 over e to the 1 half, then we get negative 1 minus ln of e to the negative 1 half, so negative 1 half. So we'd still get negative 1 plus 1 half, and we'd get a negative number. Okay, so we get negative 1 half. So that'd be a negative number. And so just to reiterate, 1 over e is the value that, let me write that better, draw that better. So 1 over e is the value of x that would maximize the area. There you go.